Hi, my name is Lenny, and today I'll be going to talk about the concept behind the seafloor spreading. So what is seafloor spreading? Seafloor spreading is a geological process that occurs at the boundary between two plates where molten materials within the earth pushes its way up, causing the plates to move away from each other. At these divert boundaries, molten materials cools and harden, creating a new oceanic crust, or what we call seafloor. But wait, who discovered the seafloor spreading? Seafloor spreading hypothesis was proposed by an American geophysicist, Harry H. Hess, in 1960s. Harry Hess postulated that molten materials from the Earth's mantle continuously wells up along the crest of mid-ocean ranges that winds for nearly 80,000 kilometers through all the world's oceans as the magma cools and push away the flanks of the ranges. At the mid-ocean range, molten material rises from the mantle and erupts. The molten materials then spreads out, pushing older rocks to the both sides of the range. Over tens of millions of years, the process continues until the oldest ocean floors collides with the continental crust. The more dense oceanic crust subducts back into the mantle at the deep ocean range. Mid-ocean ranges are the longest, largest, and most voluminous magnetic environment on Earth. It is also a continuous range of undersea volcanic mountain that encircles the globe almost entirely underwater. It is a central feature of seafloor terrain that is more varied and more spectacular than almost anything found on dry land, and includes a collection of volcanic ranges, reef, fault zone, and other geologic features. Harry used sonar as a device. Sonar determines the distance of an object underwater by recording the echo of the sound waves. Sonar bounces sound waves of underwater object and then records the echo of the sound waves. The time it takes for the echo to arrive indicates the distance to the object. In 1960s, Harry Hess examined maps of mid-ocean range. He proposed that the ocean floors move like conveyor belts, carrying the continents with them. So there are three major evidence that scientists found for the seafloor spreading in 1960s. These are the evidence from molten material, evidence from magnetic strip, and lastly, the evidence from drilling sample. So first, let's talk about the evidence from molten material. Alvin's crew found strange rock shaped like a pillow or like toothpaste squeezed from a tube. Such rock can form only when molten materials hardens quickly after erupting underwater. The presence of this rock shows that molten materials has erupted again and again from the cracks along the central valley of the mid-ocean range. Evidence of magnetic strips. In 1970s, scientists sailed back and forth across the world's ocean, measuring the magnetic signatures emanating from the oceanic crust beneath their ships. This survey revealed a series of invisible magnetic strips of normal and reverse polarity in the seafloor. The pattern reflects the creation and spreading of oceanic crust along the mid-ocean range. Basalt forming at the range picks up the existence of magnetic polarity. Divergence then moves the swath of fresh crust away from the range. As long as the magnetic field remains constant, the polarity stripes widen. When the Earth's magnetic field reverses, a new stripe with the new polarity begins. Evidence of drilling sample. This system leads to the evidence that support the seafloor spreading hypothesis. The sample obtained from the seafloor drill reveals that the rock away from the mid-oceanic ranges were relatively older than the rocks near it. The older rocks were also denser and thicker compared to the tinier and less dense rock in the mid-oceanic ranges. Subduction. The process by which oceanic crust sinks through a deep trench and back into the mantle. It is a convergent plane boundary. So at this part, we will going to differentiate subduction in two different oceans, which is the Pacific Ocean and Atlantic Ocean. Subduction and seafloor spreading are the process that could alter the size and form of ocean. For instance, the Atlantic Ocean is believed to be expanding because of its few trenches. Due to this continuous seafloor spreading occurs and makes Atlantic Ocean floor to be connected to other continental crust, making the ocean gets wider over the time. On the other hand, the Pacific Ocean has more trenches that lead to more subduction of ocean crunch rather than the formation of mid-ocean ranges. The Pacific Ocean is believed to be continuing to sink. So we are done with our topic. I hope this video helps you understand the concept behind the seafloor spreading and its evidence. Until next time, bye-bye!